So this video is going to have some guided practice. So if you look in your module packet at Guided Practice Strategy 1, we're going to go through that problem and the problems that follow. Okay, so the first one says calculate the wavelength in meters of radio waves having a frequency of 2.5 times 10 to the 6 hertz. Okay, the first thing I need to do is figure out what that stands for. So hertz is the unit for frequency, or if you just look through and read that problem again, it says having a frequency of 2.5 times 10 to the 6 hertz. Okay, the next thing I need to do is figure out what I'm looking for, and the problem says to calculate the wavelength. So that is what I'm trying to find. Okay, so regardless of which strategy we use, we're going to look at two different strategies here. The first thing you have to do is pick your equation. So I'm going to write down our two possible equations. Okay, and so now I need to look at what I have. I'm given F. Well, I have F in both of these, so that's good. I'm looking for lambda, or wavelength. I only have that in the top equation, so I'm not going to be able to use that bottom equation. I'm going to cross that out. And so that's how I go about choosing my equation. So I'm going to write this down, and if we remember correctly, c is the speed of light. We always know what c is. It's the same number, 3.0 times 10 to the 8th meters per second. Okay, so now I'm going to start with the strategies. The first strategy, strategy 1, will be algebra. So I'm going to plug in, I have my equation right here. I'm going to plug in what I know. So I have 3.0 times 10 to the 8th meters per second equals, I don't know what my lambda is, so I'm going to leave it there. And my frequency is given in the problem, 2.5 times 10 to the 6th, hertz. Okay, so now in order to get lambda by itself, I have to divide on both sides by 2.5 times 10 to the 6 hertz. On the right here, it's just going to cancel out, and it leaves lambda by itself. Okay, on the left, I'm going to have to put all this in my calculator. So I'm going to show you how to do that in green at the bottom, because it is a little tricky with that scientific notation. So what you're going to do, here, I'll put it right here, 3, and then you're going to push the second button and then the EE button. And the EE button on your calculator also has x to the negative 1 on it. Okay, then you put the exponent, which is the 8. Now we're going to do divided by, that's the function we're doing, and then we put in the second number, and that's going to be 2.5 second EE, and then the exponent, which is 6, and then you push the equals sign. And when you do that, you're going to get your answer at the end, and that's going to be 120 meters. And that is my wavelength and my final answer. Practice problem. Okay, it says calculate the energy of a wave having a frequency of 4.2 times 10 to the negative 3rd seconds to the negative 1. Okay, seconds to the negative 1 is the same as 1 over seconds. Okay, and that is one of our units for frequency. Okay, and it says in the problem that this is the frequency. Now I need to know what we're looking for. It says calculate the energy. So that's my question mark. Again, regardless of strategy, you need to start with these steps. So we are going to pick out our equation. We have two possibilities. If I look, I was given frequency. That's in both of these. And I'm looking for energy. That's only in the bottom one, so I'm going to cross that top one off. I do have H in there, so if we think back and remember about H, that's our constant. It's Planck's constant. It's 6.63 times 10 to the negative 34th joule seconds. Okay, so now I'm going to start the first strategy. That is to use algebra. I'm going to plug in what I know, my H, and then my frequency. Okay, my seconds are going to cancel out, so I'll end up with joules. And then I'm going to put this into the calculator. Again, I'll show you how to do that, okay, because it is tricky with that scientific notation. So we're going to put 6.63 in, then you push your second button, your EE button, and then negative 34. And then you need to do your operation. This time we're multiplying. 4.2 second EE negative 3, and then equals. And when we do that, we're going to get our final answer, which is our energy will be 2.78 times 10 to the negative 30th joules. And that's my answer.